All right, so I had a bit of an issue with losing some content. I think this should just be a one-time thing because I did not realize the significance of clicking versus hitting space when indicating that you want to do full screen recordings in Descript. Regardless, okay, so far I've been working on chapter 7 of The Little Schemer. And so far, what we've been doing is we looked at writing a procedure that tests for whether a list of atoms is a set, set being defined as a list of atoms where no atom appears more than once. And then we made a procedure that makes a set, which basically removes duplicates from a list of atoms. And then we looked at writing a procedure that figures out whether a list of atoms that's the first argument to the procedure is a subset of the list of atoms that is the second argument to the procedure, subset being defined as all the atoms in the first procedure are somewhere in the second procedure. So that's where I've gotten so far. All right. View, enable scrolling. Okay. To be able to scroll so I can only see the next question as opposed to it like flipping to the next page entirely. All right, so the question I wasn't sure about was they want us to write subset with and. I wasn't sure how to do that. Okay, so I think I figured it out. So we get rid of so in the first version, we did null. If null set 1, then true. If member car set 1 and set 2, then we do a recursive call, else false. With this style of approaching it, we still check null, but then otherwise, we see whether the first element of set 1 is a member of set 2. And that's within an and expression that also contains a recursive call to my subset with the rest of the list, the rest of set 1 and the entirety of set 2. So basically, it's just a bit shorter. Whether the first element of set is a member is still getting checked. The procedure will still return false if any given element of set 1 is not a member, because as we do the recursive calls and as we go through the elements of set 1, sort of building up a chain of ands, and like everything in an and has to be true or else the and returns false. So if there's anything in the chain of recursive calls that winds up being false, it's going to percolate back up and then we're going to return false. So yeah, right there. This was my solution. Let's see what they did. Yep, so they did exactly the same. Their solution was the same. Okay. Yeah, I didn't see that solution immediately, but I figured it out. So it's all good. What is EQ set 1, set 2, where set 1 is 6 large chickens with wings, and set 2 is 6 chickens with large wings. I'm thinking this is going to be, well, I mean, you could define it different ways. I would think it would be false because if you were to define it in such a way as be true, then this would, I mean, it wouldn't quite be like subset, but it'd be kind of overlapping with subset. So yeah, I think it's going to be false. Oh, okay. So I guess you're just looking as to whether each element in the first list appears in the first set appears in the second set the same number of times or something like that. So the way I'm thinking of this is, okay, if we run out of things in set 1, then, well, if set 1 and set 2 are null, then we would return true. If the first element of set 1 is an element in set 2, then we want to recursively call EQ set with the remainder of set 1. And in place of set 2, we want a list with one copy of that element that was the first element of set 1 that is also in set 2. We want one copy of that removed. All right, so this is working as expected. First, we remove the 6. Then we remove the large, and the chickens, and the width, and the wings, and then both are empty, and so we return true. Now, it's worth probably testing another couple cases. 6 large chicken with a wing in the first one. All right, so that's false. And let's give it an extra value. Wings versus wings. Yeah, that's okay. So this seems to work okay. Can this be made any simpler? It seems like we could maybe do the same thing I did before in terms of making it simpler, where that I did for my subset 2. Yeah, so we can have the similar structure where we have the null check and then the else with the and joining the member check and the recursive call. I think that works. All right, so they have a different approach where basically they check whether set 1 is a subset of set 2 and set 2 is a subset of set 1. Because if that's the case, if they're both subsets of each other, then they have the same elements. And that makes sense, and it's building on the existing procedures more. Right, conline, sure. Well, why do they even want a conline? You could just do it in a one-liner. Yeah, I'm just going to see what they mean by one conline. Okay. Yeah, see, at that point, I just don't know why you just don't do and as opposed to cond. Like, just get rid of this and just have that as like a one-liner, basically. Write the one-liner. What is intersect set 1, set 2? Where set 1 is stewed tomatoes and macaroni, and set 2 is macaroni and cheese. So I think it would be and macaroni. Oh, it's a question mark, so it's, I see. True, because at least one atom in set 1 is in set 2. So it's do they intersect at all? Is basically the meaning of the procedure. All right, so set 1 is empty, return false. If the first element of set 1 is a member of set 2, return true, because that's all that needs to be true, at least one atom. Otherwise, recursively call my intersect, or intersect, it's my intersect in my version, with the remainder of set 1 and set 2 as arguments. And we see when there's overlap, we get true, and when there's no overlap between the sets, we get false. So we see this was the same, my solution is the same as their shorter version. Try writing intersect with or. I'm finding this useful, by the way, like we're getting multiple practices with using and then now they're introducing or, and they're not just introducing stuff and then moving on. There's sort of some drilling built in, which is good, which is important and necessary. Right, so or makes sense because we're looking for any time that the member of the first element of set 1 is a member of set 2. That happens anytime in the recursive chain of procedures, we want to return true for the whole procedure. So whether it's, on the first word or in the recursive call on the second word or whatever. That's why we can use or. Let's make sure that this works. Oops, still a typo. No, I'm using the wrong version. Okay, that's false, correct. And this should be true. Yep. You can see we agree on intersect with or. Oh, so now we've gone from intersect question mark to just intersect, which is how I initially read it. I think this would be and macaroni. Yep. Alright, so here's my version of my intersect. If set 1 is null, and then if it is, we return the empty list. Otherwise, we check if the first element of set 1 is a member of set 2. If it is, we cons the first element of set 1 onto the value produced by a recursive call to my intersect with the rest of set 1 and the entirety of set 2. Otherwise, we recursively call my intersect without consing anything with the arguments the rest of set 1, or coulter of set 1 and set 2, which effectively skips the first value of set 1. We only retain set 1 if it's a member. And we only go through set 1 because we're looking for the intersect. So when set 1 runs out, then there's going to be no more intersect. Like, it doesn't matter what's left in set 2 at that point, I guess is the point. All right, so let's see. Return the empty list. If member, yeah. So they agree. So now what is union set 1, set 2? Where set 1 is 2 tomatoes and macaroni casserole. Set 2 is macaroni and cheese. I'm betting it's going to have something like all the elements from both. So stewed tomatoes and macaroni casserole cheese. Something like that. Yeah, it looks right. All right. So looking at union, and basically what union does is create a set that has at least one, or that has one copy of each element within two sets. And I'm wondering if just looking at the output we can figure out something about how it works. Because you notice my first guess as to what the output would be something like stewed tomatoes and macaroni casserole cheese. Whereas here we have stewed tomatoes, casserole, macaroni, and cheese, which I think says something about how the procedure works. Yeah, so I'm just sort of trying to reason about it. So thinking it might be like, if the first element of set 1 is in set 2, then we ignore it. We don't do anything. Or I should say, we go to the next element in set 1. And then when we get to the base case, we say, instead of returning null, maybe we return set 2. I think that fits. Yeah, I think that fits. Yeah, so see, we return set 2. If the first element of set 1 is a member of set 2, we recursively call my union with the remainder of set 1 and the entirety of set 2. So we skip over that element that's a member. And otherwise, we cons the first element of set 1 onto the value returned by a recursive call to my union with the remainder of set 1 and the entirety of set 2. All right. So let's see what they did. Null set 1 return set 2. Remember, first element of set 1 and set 2, then recursive call, yeah. Else, yeah. So now they're asking, what is this function? So we've got two sets. When set 1 is null, we return the empty list or set. If the first element of set 1 is a member of set 2, then we recursively call the mystery function with the remainder of set 1 and the entirety of set 2. Otherwise, is this the same thing? Otherwise, we cons the first element of set 1 onto the result of a recursive call to my union, or to XXX, with the remainder of set 1 and the entirety of set 2. That seems like the same thing. Oh wait, no, it's not. It's not the same thing because of the base case, which is different. I see. So this returns only the elements that are unique to set 1. Right, so in their words, it is a function that returns all the atoms in set 1 that are not in set 2. That is, x is the set different xxx is the set difference function. What is intersect all L set, where L set is this thing? So since intersect consists of the elements that appear within each of two lists, I'm guessing that intersect all is going to be the list of elements that appear within 3 or more lists. We've got A and C as overlap, and then just A of, so just A I think would be, yeah, A. Okay. All right, I really needed to think about this one. So they say, using whatever help functions you need, write intersect all, assuming that the list of sets is non-empty. So for some value to be intersect all, it needs to be in all of them, and all of the sublists of the list of list L set. So I decided, well, so we already have member, which can find whether a value is in a list. So I did member any, which figures out whether a value is in any of sublists and returns true if it is and false if it isn't. So for example, is A a member of this stuff? Sublist ABC and sublist DEF. Yes, it is. And so we return true. Otherwise, so like if is H a member of sublist ABC or DEF? No, so we return false. And that's pretty straightforward to code. You know, lambda value list. If list is null, return false. Otherwise, return true if either the value is a member of the first list or a recursive call to member any is true. So it's pretty straightforward. And so then, I just realized I don't know if this will actually work. Yeah, it's awkward because then I want to say like, well, if the first value of the first element is a member of any of the sublists that remain in the L set, then cons the first value of the first element onto the value returned by recursively calling my intersect all with all but the first element of the first list. Like it's getting too convoluted and weird. I'm just going to see how they did it, I think, because I'm not sure how to proceed. Okay. All right, so how they did it. Oh, wait. That's intersect. I lost my place. All right, for some reason, I didn't lose the video, but like the audio didn't record on a chunk of material. I'm not sure why. I was having some performance problems that could have been related to it. So I restarted my computer. But anyway, so I wound up just looking at what they did for intersect all, and I wrote it up. And it makes sense to me. So yeah, that one I just looked at. So you can read the write-up on the blog post. And we've got pair. Is this a pair? Yes, because it is a list with only two atoms. Oh, we want to change this to. How do I permanently change? Wait, where's. Oops. It's in the wrong menu. Page display. Enable scrolling. Okay. All right, so a pair is a list with only two S expressions. How do we define S expression earlier? All lists are S expressions. All atoms are S expressions. All lists are S expressions. Okay. Because I realized I tried to change the resolution to 1440p, and I wonder if that's causing a problem. So I tried to change it down to 1080p. All right. So I ran my pair checker, a pair, on their examples that they say should all be true. And you see, it's very simple. It basically just tries to see if there's a third value. All right, so the last one, it returns false because there's a third value. But otherwise, it just takes kutter of the list and checks if it's null. And if it is, it says it's a pair. And if not, it's not. So that's really straightforward. Okay. Theirs is a lot longer. Oh, I see. So, yeah, I was wondering if mine was just like a super elegant way of doing it. But you see, if you just use one value, if you have a single valued list, then you get an error message. Whereas with theirs, it would see that the 3 is an atom and just return false, as opposed to giving an error message. Right, the other case, yeah, I should have thought more carefully about the cases here. I was just looking at the examples. Right, so if you just have the empty list, they would catch that and return false. But here we also get an error message. So if you have a one valued list that's not an atom, right? Because the empty list isn't an atom. So if you just have like a nested empty list inside the empty list, again, mine gives an error message, whereas theirs returns false correctly. We're going to refer to the first S expression of a pair. Car of the list? Of the pair? Yeah. We're going to refer to the second expression of a pair. Car of Cutter? Yep. How can you build a pair with 2 atoms? You use cons? I'm not sure. You say cons of the first one and cons of the second one onto empty list. Yeah, okay. Cons x1, cons x2 quote, empty list. Yeah, sure. How can you build a pair with 2 S expressions? You cons the first S expression onto the second, like the same thing? First expression onto the second S expression onto the empty list? You cons the first one and the cons of the second one onto the empty list. Yeah, okay. Did you notice the differences between the last 2 answers? Okay, let's see. I don't know. It seems pretty close. Let's see what they say. No, there aren't any. Okay. So now they introduce these 3 functions, which they say are used to make representations of pairs and get parts of pairs. Parts of representations of pairs. First, second, and build, and they want them as one-liners. Pretty straightforward. Oops. All right, so let's see. You write third as a one-liner, sure. Car, could be. Or L, sure. Is L a rel where L is, I don't know what a rel is. I don't have a guess. No, since L is not a list of pairs, use rel to stand for relation. Okay. Is L a rel where L is apple, peaches, pumpkin pie, apple, peaches? Or apples, peaches? Yeah, I think so, because we have a pair, and a pair. So yes. Oh. Wait. I forgot our definition of pair already. It's a list with only 2 atoms. Wait a second. What do you mean? So this has to be yes, right? Yes. Why is this a rel and this isn't? I was thinking maybe it has to be an even numbered set, but there's 5 pairs here. So now they're asking, so I'll just put that rel example to the side for now. Now they're asking, is rel a fun where rel is that? And I don't know. No, we use fun to stand for function. What is fun rel where rel is this? True, because first rel is a set. See chapter 3. A set is a list of atoms where no atom appears more than once. Well, based on what they said, I think since B appears more than once in this rel, then no. I see. A rel is a list of pairs that is a set. A set, right, so a rel is a list of pairs that is a set. A set is a list of atoms in which a value doesn't appear more than once. When considering whether, maybe, right, so a rel is a list of pairs that is a set. A set is a list in which no value appears more than once. Since apple peaches appears more than once in the list, it's not a set. So a function is when each first value in a list of pairs is a set, doesn't appear more than once. Right? Since this rel has 4 appear more than once as the first value, it is not a function. I'll just say relation for these. Whereas since this relation has all unique first values, it is a function. This would be false because we have B and B appearing in 2 places. Okay. So write fun with set and first. So this should be really simple. Seems to work. All right. Agree. Is fun a simple one-liner? Sure is. How do we represent a finite function? For us, a finite function is a list of pairs in which no first element of any pair is the same as any other first element. Okay, I think I said that already. What is rev? I don't know what rev is. Oh, just reverse. Wait. Oh, yeah. It just reverse each element. Oh. Here we go. Okay. Okay, so that was pretty tricky. Probably a better way to do this than using 3 cons. But yeah, I basically just figured out how to reverse stitch together each pair by using cons car. It was a bit trial and error. Now that I've done it the long way, I'll try and use these procedures, these helper procedures. Actually, I don't know if they're that helpful. Yeah. All right, I squinted and it looked like their version of RevRel was short, but not super short. It could be roughly what I did, so we'll see. Yeah, okay, so they did use the helper procedures. The null starts out the same. Yeah, so I was thinking like it should help more or something for us to use the helper procedures, but it does help a little bit. So you use build, and that lets you get rid of the cons to the empty list, and then use second, and that lets you get rid of the card cutter. Hang on. Okay. Yeah, I went in and substituted their helper procedures, and yeah, I see how it cleans it up. And then they ask, would this also be correct? And they did the version that I did, basically. And they're like, yeah, but do you see how representation aids readability? And I do. I think I do. Okay. Okay. Suppose we had a function rev pair that reversed the 2 components of a pair like this. Suppose we had this function rev pair that reversed the 2 components of a pair like this. How would you write rev_rel to use this help function? And it makes it even more readable. Can you guess why fun is not a full fun, where fun is 8342766234? Because there's more than 1 second value corresponding to a first value or something? I don't know. Since the 2 appears more than 1 as the second item of a pair. Okay, so that was right. Can you guess why? What is the truth value of full fun where fun is? Let's see, 3, 8. Well, actually, let's make sure it's 8, 4, 7, 6, 3. So those are all okay. 3, 8, 6, 2, 4. Those are okay. So yeah, true. Oh, I misread this. Why is true the value of full fun? I guess we're assuming it's a function, and so we're just checking for the fun, so we can just check the second values. Because 3, 8, 6, 2, 4 is a set. Okay. What is full fun where fun is grape raisin, plum prune, stewed prune? False. Because prune. What is full fun where fun is grape raisin, plum prune, stewed grape? True. Because raisin, prune, grape is a set. Do we have a seconds function? Tomato cream. Okay, we do have a seconds function. So we're gonna blow this one away. Okay. Right, so we see it just checks whether the seconds are set. We're assuming basically that fun is a function. And so when they are set, it returns true. And when I made it so that 3 appeared twice as the second value, it returned false. Can you define seconds? Ooh. 3, 3. Oh, and you get a list. Okay. So basically, my seconds, we get the second value of the first element. We cons that onto the value returned by a recursive call. So 3, 8, 6, 2, and we get to the case where cdr is null. That's this case, where we have a nested list of two values. And cdr is null because, there's only the one sublist. There's nothing else. So when we get to that case, we take car, which gets us the list, as opposed to it being nested, and we take cdr, and that gets us the list number, and we actually want the number in a list form because we're going to cons onto it. All right. Okay. They say it's just like firsts. Did we define first? Right, so we defined first quite a while ago. It seems like it's different enough to be worth talking about. What is another name for full fun? I don't know. One-to-one? You think of a second way to write one-to-one? Oh, I should have thought about it. Oh, I see. So if you just flip them all, if you just flip them all, then you can just see whether they're a function. Okay, that's cool. Is chocolate chip doughy cookie a one-to-one function? I think so. And you deserve one now. Didn't get one, or better yet, make your own. Okay.